This video will start section 5 in our statistics OER course that pertains to continuous random variables. We will discuss continuous probability distribution function or continuous PDF in this video, but the rest of the chapter covers the uniform distribution, the standard normal distribution, and how we use the normal distribution. And in our course, the Lumen textbook covers these topics in Module 5 and 6, and the OpenStax statistics course also covers these topics in Module 5 and 6. This particular video pertains to section 5.1 of the Introductory Statistics class on continuous probability functions, and in Module 5, continuous probability functions in the Lumen textbook. So, a continuous probability function pertains to a numerical and continuous variable. We define the continuous probability distribution function in a way that the area between the curve and the x-axis equals the probability. So we have a function f, and f of x is such that the area between the graph and the x-axis equals a certain probability of values. And since the sum of all the probabilities of the values of the variables in the sample space has to equal 1, the total area has to equal 1. So if we have a function that has f of x equals 1 over 20 or 0.05, and remember from algebra that f of x equals the y value. So the y value is 1 over 20. We want a function that is such that the area between the function and the x-axis to add up to equal to 1. And since the line y equals 0.05 is a horizontal line, the graph or the shape between the x-axis and the function is a rectangle. And the rectangle has area equal to base times height. And the height is here, and it is equal to 1 over 20, which is the same with this length on the y-axis. So then the question is, what's the base? So if we want the area to add up to 1, and we are looking for the base, and the height is 1 over 20, or 0.05, to solve for the base, we will multiply by 20. So the base will end up being 20 times 1. That means if x starts at 0, this b will have to equal to 20. The domain of the function, which is the values of x, will be x less than or equal to greater than or equal to 0 and less than or equal to 20. In interval notation, bracket 0, 20 bracket. So if they are asking us to find the area between f of x and the x-axis from 0 to 2, then what they are asking us to do, if this is the axis and this is the graph of the function, 1 over 20, and we have a base that starts at 0 and ends at 2, they are just asking us to find this area. So this area will equal base times height, and the base is from 0 to 2 equal to 2, and the height is 1 over 20, so that will be 1 over 10 or 0.1. And since the area is a probability, then they are asking us to find the probability that x is greater than 0 and less than 2. And that will equal to the area from x equals 0 to x equals 2 and between the x-axis and the graph. Therefore, that will equal to 0.1. So to find the probability that x is between 4 and 15, again, they are asking us for, this is the graph of the function. It goes from 0 to 20. It has a height of 1/20th, and it's a horizontal line. So the probability from 4 to 15 will have to equal the area under the curve from 4 to 15. So this probability will equal to base times height, because this is still a rectangle. The base is 15 minus 4, 11 units, and the height is 1 over 20, which is always f of x, since the function we are working with is f of x equals 1 over 20. So that is 11 times 1 over 20, which is 11/20ths, or 0.55. Now, suppose that we have a continuous variable and we want to find the probability that x is equal to 15. The problem with continuous variables is that, again, if this is my function and it goes from 0 to 20, and they're asking me for x to be exactly 15, then this rectangle has a base equal to 0, because 15 minus 15 is equal to 0. And therefore, the probability of x equal to 15 for any continuous variable will equal to 0, because that rectangle does not have a long enough base to give us a particular probability. Now, continuous variables, we have seen in the past when we were discussing what type of variables we'll have, would be something like a distance, or say the time. So let's assume that we have an example of how long does it take me to get to school every day. It is very unlikely that I will say that it will take me exactly 15 minutes and 0 seconds and 0 tenths of the second to leave my house and to get to the school. So the concept is that a continuous variable has no probability, 0 probability of having exactly a specific value, but we could have a probability of the time that it takes me to go to school to be up to 15 minutes, or to be from 15 to 16 minutes, something like that, to be at a particular interval of values. So think of that when we are discussing continuous values in this chapter. So for continuous values, for continuous distribution, the probability of x less than or equal to a particular value, little x, is the same as the probability of x being less than that little x. So it doesn't really matter if you say, are you going to be equal to x or are you going to be less than x? It doesn't matter if I say if it takes me less than 15 minutes to get to work, or if I say it takes me at most 15 minutes to get to work. And this is called the cumulative density function, CDF. We can use the CDF to calculate the probability that the value of x is greater than little x, because it will be the area to the right of the value little x. And you can find this, you can use the CDF, because the CDF will give you the area to the left, and the area to the left is this area from whatever is the lowest value of x, assume 0 for now, to the little value of x on the left, on the right there. And the probability of x being greater than x is the remaining probability. So the CDF gives me the area to the left if I want to find the area to the right. Since the whole area has to equal 1, then the probability of x being greater than the value x will be 1 minus the CDF, the probability of the variable x having values less than or equal to x. So that's one way to calculate probabilities of your variable having values greater than some quantity, but we can also find the probability that the value of the variable will be between certain values. So let's do an example here. We have f of x here is equal to 1/8. So first of all, we need to find the domain. Remember, if we start at x equal to 0, how far can we go until the area under the curve totals 1? So I want all of this area to equal to 1, if that is to be a probability density function, a PDF. So if I want the area to equal to 1, and the area is base times height, the base is b, I don't know it yet, the height is 1/8. If I multiply by 8, I will get 8 equals to b, so I found the upper limit for x. So the domain will be from 0 to 8 closed on both ends. That's also written 0 less than or equal to x less than or equal to 8. It's the same. The notation for interval notation is for continuous variables that take all the values between a lower bound and an upper bound. So if they are asking me to find the area between certain values, so between 2.5 and 7.5, and I have to find this area. This area will be base times height. The probability is the area, so that will be base times height. And the base is 7.5 minus 2.5. This is 5 units. And the height is the function value, 1/8. So I will have 5/8 as my probability, or 0.625. So in this video, we talked about continuous probability distribution, and the total area under the curve must be equal to 1. And we talked about the fact that the probability of a particular value is of the variable equal a particular value is equal to 0, and how we can find the probability of the variable being below a value, above a value, or in between two different values.